In our previous video lecture, we are introduced to the graphs of the sine and cosine functions. In this video lecture, we're going to talk about their amplitudes. Our objective, we want to determine the amplitude of a sine or cosine function. Well, let's first define the word amplitude. And the amplitude, in discussing trigonometry, is the height from the center line to the peak or to the trough is the amplitude of a sine or cosine function. The amplitude is always positive. There's no such thing as a negative height. So your amplitude, no matter how you measure it, from high to low or from low to high, it's always a positive number. And that should tell us that we're going to be thinking about absolute values somewhere. When something is always positive, then the chances are good we're going to be discussing absolute value, because absolute value is always the positive. The amplitude can also be found by measuring the height from the highest to the lowest point and dividing it by 2. So you can go from the center line to the top, or from the center line to the trough, the bottom, and that's the amplitude. Or you can go from peak to trough and then divide it by 2, and you'll also get the amplitude. Okay, let's remind ourselves about these basic sine and cosine functions. So a quick sketch. Nothing fancy. The sine function always goes to the origin, and from 0 to 2 pi, and these should be the same amplitude, of course, so approximately that. Remember, this is pi, this is 2 pi, and that's one period, one full wave. And we recall that it got as high as +1 and as low as -1. So if we go from the center line to the height, from the center line to the peak, or from the center line to the trough, this is the amplitude, which equals 1. Now I can rewrite, here we have y of sine of x, and it'll help us to for how this lesson is going to go. We could put a 1 right here in front. This is y equals 1 times the sine of x. Remember, there's often or almost always an assumed 1 in front of a lot of these things. So we could say y equals 1 times the sine of x. The amplitude is right in front here, 1. Let's do the same thing for the cosine of x. Okay, just again a quick sketch. It goes from 1 to -1, as you recall. It started at 1. It did not start at the origin. It went down to -1 and back up to 1. And again, that was 0. This is pi. This is 2 pi, and the zeros of this took place at pi over 2 and 3 pi over 2, where it intersected the x-axis. And, well, here's the center line to the peak, either here or here. And here is the center line to the trough. And again, this, and this one. These are the amplitude. And the amplitude is equal to 1 in the basic sine and cosine function. So here it is, y equals the cosine of x. And again, we could put a 1 in front there. Y is equal to 1 times the cosine of x. And what I'm leading you to see here is, if I put a 2 here, then whatever the sine function does gets doubled. Okay, and the curve will get higher and lower. If I put a 3 here, whatever the cosine function outputs will be then multiplied by 3 and get higher and lower. So this number in front of the sine or in front of the cosine function is going to be a multiplier that's going to determine our amplitude. Let's take a look, okay? And so you'll notice here, I wrote that down here, the amplitude can be changed by multiplying the function by a number other than 1, right out here in front. Let's look at this one. Example 1, plot the graph of y equals 2 sine x. Okay, so whatever I put in, now remember, we're still in radians, and I'm still going to do my normal. I'm going to cut it into, I guess I'm going to cut it into twelfths. So let's remember how all this works. Here's my pi over 2. Here's my pi. Here's my 3 pi over 2. Again, a quarter of the way around the circle, halfway around the circle, 3/4 away around the circle, and then all the way around the circle is 2 pi. And I'm going to cut each of these into thirds, 30, 60, 90, 120, etc. if you're thinking degrees, but in radians it looks like this. And I got these two backwards. I bet you probably caught that, didn't you? Do not rely on me being perfect, because I am not. Anybody thinks that others are perfect is crazy. I'm not perfect. Make mistakes. Hope I catch them. Okay, so 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, etc. And again, I'm not going to get the calculator out. We know how to do this. Put in 0. The sine of 0 is 0 times 2 is still 0. The sine of pi over 6 is a half. A half times 2 is 1. And we'll continue on. This is 1.73 approximately. The sine of pi over 2 is 1. 1 times 2 is 2. And we saw a pattern similar to this in our previous video lecture. Okay, it starts at 0. In this case, it goes up to a height of 2 and comes down to 0. Now it's going to go down and come back, because we know the sine of, we know when 2 pi goes in, the sine of 2 pi is 0 times 2 is 0. And so with your calculator, if you need to, this is -1, -1.73, -2, -1.73, and -1. Okay, so let's take a look. Again, I'll be a little bit more precise. I will do my, my main units as inches with the graph I created here. I need to go to 2, so I'm going to go with 1 inch. It looks like it barely fits. I just made it just the right. So this goes from 2. That's my highest point. My peak is at 2. My trough is at -2. And let's see. So I'll just put them in. Oh, I almost forgot. I'm going to cut this into thirds. Alrighty, and so we're just going to plot. When x is 0, y is 0. When x is pi over 6, y is 1. Oh, I should put a 1 in here probably. That'll help me. Let's put a ½ inch here to mark a 1. Be a bit more accurate. And how about a -1? That'll probably help. Whoops, and I got a little bit below the graph. Sorry about that. I just noticed that I didn't move the paper up enough. So again, x is 0, y is 0. When x is pi over 6, the sine of 2 times the sine of pi over 6 is 1. Let's see, this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi, our key points. This is my pi over 6. This is my pi over 3, and so on. Twice the sine of pi over 3 is 1.73, ballpark here. Twice the sine of pi over 2 is 2. And then I come back down. This is 1. Here's my 0 again. I come down to -1/2. Whoops, -1, excuse me. Okay, -1.73, -2. And then I go back to here, and I go to here. So this can go on to -pi over 6. We know that this curve continues in either direction, but I'm really focused on between 0 and 2 pi, which is 1 time around the circle. Whoops, I missed that one. There we go, and there you have it. Y equals 2 times the sine of x. Okay, so we look at that number right in front, the number 2. Well, the distance from the center line, which is the x-axis, to the peak is 2 units. That's the amplitude. Same thing here from the center line to the trough. I guess I got to kind of go around this a little bit. There we go, is also 2 units. Okay, we measure height with a positive number, so just because I went from the center line down doesn't mean it's -2. There's no such thing as a -2 height. The amplitude is 2 in the graph of y equals 2 sine x. Amplitude, that was the question, is equal to 2. Okay? And so again, you see as you multiply on the outside by a number, in this case it's a +2, and the graph went higher and lower. It doubled. It was 1. The height and the depth was 1. The peak and the trough was 1. And when I multiply by 2, the peak and the trough both became 2 in this case. And so the amplitude from center line to the peak, or from center line to the trough, is 2. Let's do an example with a negative number in front and see what happens with that. All right, get my paper set up here. So I'm going to plot the graph of y equals -3 times the cosine of x. So we want to notice in front here we have a negative number. Now remember, amplitude is the height. We talked about the fact that height is always positive, and that when we're thinking about things that are always positive in mathematics, the absolute value is going to come into play. Because the absolute value makes things be always positive no matter what you're doing. So let's again do our key points. In radians, x is going to go from 0. That's a quarter circle. That's a half circle. That's 3/4 circle. That's a full circle. And I divide each of these into thirds. And I should have this memorized by now, but I'm still a little bit slow. 5 pi over 6 goes here. 6 pi over 6. 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Okay, there we go. Now, with our calculator, let's put in, we know the cosine of 0 is 1. 1 times -3, and we're starting off at -3. So I'm going to come down to here, and I'm going to go ahead and I'm going to make my key marks for my quarter circles. Pi over 2, pi, half a circle, 3 pi over 2, 3/4 circle, 2 pi. -3, Okay, I'm going to have to go to positive and -3. So 1, 2, 3. So here's -3. And I'll do the same thing here. 1, 2, 3, because I already know what's going to happen, so I'll go up to 3. The advantages of already having done all of this several times. And when x is 0, -3 times the cosine of 0, the cosine of 0 is 1, and I get -3. Well, wait a second. Cosine usually starts up here. So we're starting down here for some reason. Well, let's continue. -3 times the cosine of pi over 6 is -2.6. -3 times the cosine of pi over 3 is -1.5. The cosine of pi over 2 is 0. -3 times 0 is 0. So our first, going from 0 to the first quarter circle, let's put in our marks for pi over 6 and pi over 3. And pi over 6 is -2.6, ballpark here. Pi over 3 is -1.5, ballpark here. Pi over 2, of course, is 0. So you can see, what are we doing? We're coming in, well, normally we were coming down. Now we're coming up. So it's kind of like a mirror almost. We almost kind of taken it from here and mirrored it down here. Let's continue filling out our table of values. And I'll just fill them in. This is 1.5, 2.63. This is 2.6, 1.50, and this is negative 1.5, negative 2.6, and negative 3. So let's put in my tick marks here. And let's see, this is going to be 1.5, 2.6, 3, 2.6, 1.50, negative 1.5, negative 2.6, and forgive me for if I'm not totally accurate. And here we go. Let's connect these. Go like that. Come on down. And go like that. So there is the graph of here's the cosine graph, y equals negative 3 cosine of x. Well, what do we notice? From center line to peak, this is our amplitude. Again, the center line in this case has been the x-axis, and the amplitude in this case is 3. And we can also see it here as center line to trough. And here is also a center line to trough over here. Again, those both have 3. So the amplitude turns out to be the absolute value of what's in front here. It's a negative 3. So what did the negative do? Well, the negative kind of reflected it about the x-axis. Remember, cosine would have gone like this. We've been starting above, coming down, and then going back up. But the negative inverted the graph. It flipped it about the x-axis, okay? And the amplitude, again, is the absolute value of what's up here, okay? The negative said flip it or invert it, but the 3 still represents the amplitude, or the absolute value of the negative 3 represents the amplitude. So let's pull in a few things about we've seen in this so far. The graphs of y equals a number times the sine of x and y equals a number times the cosine of x have amplitudes equal to the absolute value of what that number is. If the number is positive, the amplitude is the number. For example, 2 sine x. If the amplitude is negative, it's the absolute value of that number. For example, negative 3 cosine x, the absolute value of negative 3 is positive 3. If a is negative, again, we just saw that right here with the graph of, this is y equals the, negative 3 times the cosine of x. If the a is negative, the graph or the curve is inverted about the center line, which in our example so far has been the x-axis. We may see that change in future lessons. But we're on the x-axis, and we simply did a reflection, an inversion. What was high became low. What was low became high about the center line. Okay, number 3. Between 0 and 2 pi, we notice that the sine function has zeros. Zeros are where it crosses the x-axis at 0, pi, and 2 pi, and maximum or minimum values at pi over 2 and 3 pi over 2. Let's take a look here. Okay, it has zeros at 0, pi, and 2 pi. It has a maximum in this case at pi over 2 and a minimum of 3 pi over 2. So there's one reason I kept emphasizing the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. In the sine function, they're either zeros or they are maximums or minimums. In the cosine function, coming back to here, let's make sure I get my paper. In the cosine function, the zeros are at the pi over 2 and 3 pi over 2, pi over 2 and 3 pi over 2, and the maximum or minimums are at 0, pi, and 2 pi. If you look at this one with the negative 3 cosine of x, There's a minimum here at 0, a minimum at 2 pi, and a maximum at pi. Okay, so again, once again reminding you, the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi are some key values we want to keep on top of. Okay, and the last 2 points, just to keep reminding ourselves, the sine curve or graph still passes through the origin. It still went right through there. And the cosine graph or curve still does not pass through the origin. Okay, and the reason I have it kind of it does not pass through, you'll notice that when the cosine has an amplitude that's negative, where it passes through moves. If this was positive 3, we would have started up here. The negative doesn't affect the sine function because the sine of 0 is always 0. So the sine is always going to be passing through the origin. Okay, that covers that one. Next up, we'll take a look at everything put together and how to graph functions of these forms with a bit more information.